Happy day, YouTube. My name is John, and this is my channel, The Intermancer. If you've been following along, then you know that last episode was pretty exciting in terms of the progress of the project. We got to the end of the first draft of adding mutation behavior in the system. We also, along the way, realized that there was a problem with how we were indexing data in the data quantum. We fixed that. And at this point, I'd like to yet again make some comments about what we're doing here in general. If you'll recall, the main goal for this channel is for me to learn how to use AI out in front of everybody. I'm not using some of the more powerful tools that some of the companies offer, honestly, in large part because of their cost. I'm trying to keep my cost down as much as possible. And in part, I'm glad I'm doing it this way because it's been teaching me a lot about how the LLM thinks. And specifically, when I say the LLM, I mean Claude. I'm using Claude 4 Sonnet, Claude 4 Opus, a switch between those. But I've been learning a lot about how this particular LLM processes information and its limitations. So many limitations. Anyway, again, this is a learning experience, and I'm learning out in front of everybody. So we will continue our learning journey. We are now going to move forward into the next exciting phase of coding because we are going to start adding evaluation behavior. So, as you know, the whole point of this project, besides the learning piece, the whole point of this project is to create deterministic evaluators on time series numerical data. And so I am going, when I originally thought about this project decades ago, I wanted to figure out a system that I could use to analyze stock data or commodity data and make a lot of money. Obviously, I'm not the first computer scientist nor the millionth computer scientist to have this dream. And that's why the main goal of this project isn't really to build a system that makes me a lot of money, but more just to build a system using AI, using the generative AI, and it happens to be a genetic AI system that I'm building. In a genetic AI system, you figure out a way to encode an algorithm in some way that it can mutate and that algorithms can breed, and then you use random mutations and the winds of fate when you're breeding to try to find good deterministic algorithms for things. Before I started my very first version of this system, which I used to call the predictor, now I call it Gaia F. When I started the very first version of this system, I didn't look at a lot of the state of the art, and I'm glad. All of the state of the art was modeling algorithms as tree structures. And I'm doing something very different. I'm using organism, chromosome, gene constructs as a way to encourage certain mutation patterns and breeding habit patterns. But we'll get to that when we get into all of the experimentation. We haven't gotten to experimentation yet. But now we're ready to move on to evaluation. And since this whole system was originally conceived with financial data in mind, what I am going to do is first build my evaluators based on the Dow Jones Industrial Index data, open, high, lows, closed data for the last 10 years. And I got this data online a couple of weeks ago, so we're going to be doing all of our training on this static data set, at least initially. Okay, so the first thing I'm going to do, the very first thing I'm going to do, is I'm going to pull the data in to my project. So let's go ahead and make a new directory here, new folder, training data, using good Java conventions, even though this isn't really in the Java part. Actually, yeah, we'll keep it. Training dash data. There we go. And now I am going to pull in this data. Actually, let's do this in the file system because I got it online. Intermancer code Gaia F source resources. Where's the training data directory? Oh, I'm in test, blast. Okay, so I didn't add the directory to the main source branch, I added it to test. So we'll add it here, new folder, training data. Okay, now we should see it good. And let's see, documents, Intermancer, historical prices. Sure. I do not need to keep that in my cloud drive. So here we go. Here, it should see it. Good, everything is there. Now let's look at this data real quick. Let's close all this stuff. Close all, because that kept getting in the way. Open this, get rid of this little thing. All right, so this has date, open, high, low, close, and 10 years worth of data, starting with most recent of June 16th, 2025, going back to March 18th, 2015. So that's a good amount of data for me to do training on. Is it enough for me to do the best training on? Absolutely not. Everyone knows that every AI system wants to use as much data as possible, but this is going to be plenty of data that's good enough for what we need. Okay, and Visual Studio Code, which I don't know if I've shared this, not a huge fan, is asking me if I want to install this recommended rainbow, sure, whatever. Trust publisher and install. If Visual Studio Code is recommending it, I'll do it. And okay, what do you do? Highlights columns, query, transform, and filter. Okay, whatever. There we go. Go back to here. So now, what we're going to do is we are going to build an evaluator that is going to feed this data into, it will get an organism and then feed this data to the organism, and then it will, after the organism completely processes the data quantum, the evaluator will look at the last value of the data quantum and compare it to the open price in some number of cycles. We'll probably default it to 3 cycles. So we'll look for 3-day predictions. Of course, we'll try to configure some of that. But that is what we are going to do. And we'll be leaving the training data in historical prices, even though we're going to see it working in our test data or our test code. So that's our game plan. That's our game plan. What are we going to do here? Now, well, obviously, like we've been doing, we start with our context files. So this is in experimentation. Let's see, where does evaluation go? Mutation command, basic seeder, experiment lifecycle, seed. Classes basic seeder, that's an interface, basic seeder. Organisms, okay. Mutation command, we're going to have to revisit the seeding, but whatever. Mutation command, mutational, server details, experiment controller, okay. Evaluation, we will stick that here after the stuff with basic seeder. We will go for evaluator, interface. Evaluators are classes that grade. Organisms, giving them a numerical score. By convention, a score closer to 0 is better, as 0 can be interpreted as no deviations between predicted and actual values. Okay. So let's see, methods. You don't need public on the methods for an interface. Okay, and since everything so far has been a double, we will continue that. Double evaluate organism given an organism, capital O, organism. The evaluator evaluate returns Okay. Evaluate the given organism. That's better. Okay, now on my last video, I used the AI to give me a better suggestion for my context document, and I'm going to do that here. So for basic evaluator, the basic evaluator gets configured with a target channel and a lead cycles, lead cycle count. The basic evaluator gets configured with a target channel and a lead cycle count. Now I see I don't have to be good about this description. Just saying, it's not going to be good. This is not going to be good because I am going to ask the AI to help me make it better. The target channel is when an organism is evaluated using the evaluate method. Data quanta are fed into the organism. The basic evaluator uses the last data channel, right? That's what we call it. Organic classes, data point. Last data point from the after the data quantum has been processed. What do we call it? Quantum consumed. After the data quantum has been consumed by the organism, the basic uses the last data point from the saves the last data point from the data quantum. It after lead cycle count number of data quanta have been consumed by the organism, the basic evaluator compares the saved data point value to the value of the data point target index, not channel, index, data point at the target index. The score for a consumption cycle is the absolute difference between the target data point value and the saved data point value from lead cycle count just lead count. I'm not going to do cycle. Consumption, lead consumption count. After lead consumption count, number of data quanta have been consumed by the organism, the basic value considers. Okay, and this score accumulates for all of the remaining test data. For example, we have 10 years of data for the Dow Jones Industrial Index with date, open, high, low, close. The evaluator, the basic evaluator, will feed if the basic evaluator is configured with a target index of 1 and a lead consumption count of 3, it will first feed an organism with the first data quantum. It will, let's do a list here. It will feed an organism with the first data quantum, save the value of the final data point, feed the organism 2 more data quanta, saving the final data points along the way. Feed the organism a 4th data quantum. And compare the open value with the value saved from the first data quantum. Calculate the absolute difference between those values. As the score for the data, the 4th score at that point in the stream. Continue in a like manner through all of the test data, accumulating a score as it goes. When there is no more test data, the basic evaluator will return the score of the organism. Okay, so a couple of things. As I was writing this, I realized that I need to write the interface for the data source. Okay, and include that in here, and then I'll ask the AI to help me rewrite some of this. So, data source. An interface. Do kids still use iterators in Java? Let's see. So one of the things I've been doing here is I have been realizing that my own Java knowledge is stale in surprising places. I'll just say it like that. I've been doing Java for a while, and I've got certain habits, and some of my older habits don't match the most modern way of doing things. So I'm used to using an iterator interface for this kind of a thing, and I don't think that I even need a data source as a specific interface, because I think an iterator will do fine. But what I'm going to do is I'm going to ask Claude. I already use artifacts. Give your creation. Whatever. It probably can do a lot more stuff that I'm not doing, but right now we are just going to do this. As an old school Java developer, I am used to using the iterator interface for iterating through data. What are the more modern ways to process a data set? I think it's going to tell me how to use streams. Evolve significantly. Streams, there we go. Streams provide a functional programming approach with message chaining. So it still has iterator, but while it has old way with iterator, modern way with streams. Names is a list, but it has a stream. So then, parallel streams, big list. To directly to collections for each. Names, remove, name, okay. Names is still a list, right? Names is a list. What interface do I need to implement to provide compatible streams? I have a big data set. I have a big data set. It's not really suited for a list. I'll be pulling, you know what, just tell it my problem. I'll be pulling the data in from a file. How do I stream that correctly? All right, let's see how it does this. So it's important you learn as you go. This is a learning thing. This is a learning experience, and I'm putting it out in front of everybody. And so it's important when you learn to be willing to revisit basic things. I'm asking for stuff that was made available in Java 8. Many of my old school enterprise Java developer brethren will recognize that a lot of enterprise Java code got frozen at Java 7. Enterprise code is not known for evolving quickly or taking advantage of the newest capabilities of a language because it has to use its older stuff. And I've been an enterprise developer, and so I haven't had to use, or I've been able to use some of the newer stuff. So what I am doing here is learning. And yes, this was new in Java 8, and we're on Java 21, I think, is what I'm using in this project. And so this is something that's been available for quite some time. The only thing I can say in my defense is that I have some familiarity with functional programming that I've picked up over the years, so I'm not going to be completely lost there. But obviously, I have a lot to learn, and this is a learning experience that I'm sharing with everybody. So, for large data sets from files, streaming capabilities rather than loading everything into memory, here are the key. This is your go-to for text. Files.lines. Most common. It creates a lazy stream that reads line by line. Try, stream, string, lines, file, lines, paths, get, large file.txt. Okay. So, lines filter. Line contains error. Then map string to uppercase 40. So the try with resources is crucial. It ensures the file handle closes appropriately. Try. Where's this with resources? Okay, I'll have to ask about that. Custom streaming with buffered reader. Ah, look. For more control over parsing. For this first one, this is exactly what I'll do. Buffered reader, files, new buffered reader, skip one, map line split. Okay. We will assume it's going to do this. This will help me know what to read. Okay. So in here, the data source, it's not an interface. We're going to say the open, high, low, close data source. Do the words open, high, low, close data source. The open, high, low, close data source is configured with a file. So with a file. For now, the file is in source main resources. The file is not in, it is source main resources training data historical prices.csv. Cold prices.csv. Using, okay, the basic evaluator will do this. Okay. So for now, okay. For now, the basic evaluator will use the file at source main resources training data historical prices.csv. Using streams, it will convert each line into a data quantum and feed that into the organism. The first line of historical prices.csv is just data, it's just labels and should be skipped. The first value in each data row is the epoch date, assuming the year starts with 20. So 1, 10. Does it start with zeros? Yes. 0, 1, 10, 20, going to save this. I'm going to push it up and I'm going to see what it does. First draft of the basic evaluator description so that Claude can help me make it better. Commit and push. Okay, now let's confirm that my new branch is up here. 2 branches, good. First draft experiment, good. So now over in Claude, I'm going to my projects. I have to update this bad boy. We got to get rid of this and add the new one. First draft experiment. And like before, add the contexts and the source code. Let it sync. Okay. Rewrite the description of basic evaluator in experimentation.md. Just rewrite that one section. Let's see what it does. And I'm not even going to try with Opus. I'm just sticking with Sonnet for now. When I go in to get the code written, I'll go with Opus. It's a concrete implementation of the evaluator interface. Okay. All right. Compares. All right, so let's see this. Let's see this. Let's try that. I'm going to go ahead and take it just like that. Okay, it didn't do the formatting, so let's see. Don't need this line. Probably need to. One, two, three, four. How do I do bold? I like bold. Is that just 2 stars? There we go. Okay. thing here. How do I evaluation process? Okay, so I like using this for my markdown help. In markdown syntax, how do I do a numbered list? Okay, that's easy. How do I indent a sub list? Add 2 more spaces. Okay, so we'll do that. Data preparation. 1, 2, 3, 'Said add spaces. Okay, 2 more, so it needs at least 3. Okay, oops. Why didn't it keep all this formatting? Okay, so whatever. Okay. Basic evaluator. The basic evaluator is in the com intermancer Gaia F. Okay, get rid of that. Core. evaluate package. Okay. Now we'll push this up. Second draft of basic evaluator with Claude's help. Put that up. Okay. This is probably a good place for me to pause. The video is already going to be over 40 minutes long, if not longer. So I'm going to pause here. I'm going to keep recording. So I'll see you on the next episode. Thank you.